Well, good morning, everyone. Welcome to reunion edition of Breakfast at Blake. This is really great, a fun gathering. Lots of people in from out of town that I've visited with. I know my class has 43 out of 94 of us are here for the reunion. I think about 15 are in from out of town. So I hope everyone has a great weekend. It should be fun. Now, if I can, I'd like to introduce Blake's head of school, Dr. Ann Stabney. As many of you know, since joining Blake in 2012, Ann's led many new and powerful changes across the school's 3 divisions. Ann's deep experience and passion for developing curriculum has resulted in transformative initiatives, including our new global immersion programs. Ann has also led a deepened investment in financial assistance, helping to move the number of students who receive need-based financial assistance from 2005 when she arrived to 325 students today. She's also championed our $80 million Excellence Accelerated campaign that recently reached $77.8 million, which is a remarkable sum and just a few dollars short of its goal, which we hope to have completed by the end of this weekend with your help. Locally and nationally, Ann contributes to and stays connected to the field of education. Currently, she serves on leadership boards for the Independent School Experiential Education Network, the Independent Metro Athletic Council, and the Minnesota Association of Independent Schools. Ann also regularly presents at national conferences on issues relevant to PK to 12 education and independent school education. Ann's leadership and commitment to Blake is both impressive and inspiring, and we are very blessed to have her with us here at Blake and here this morning. So I'm pleased to welcome Ann to the podium to make the introductions for our special guests.
Thank you, Woody. I would like to start by recognizing and acknowledging our 2018 Alumna Athlete of the Year, Katherine Moos, class of 2003. Having excelled on the field and on the ice at Blake, Katherine Moos went on to achieve a successful athletic career at Brown University and as a professional athlete with Club Breidablik in Iceland. More recently, she's turned her passion for sports into a career in nutrition. As a Blake athlete, Katherine earned a combined 13 varsity letters in soccer, hockey, lacrosse, and track and field. She was named All-State and All-Conference multiple times in soccer and hockey, and was also a member of the 4x400 relay team that once held the school record. Katherine led her teams to 2 state championships, one in soccer and another in hockey. As a senior, Katherine was elected captain for both soccer and hockey and was named one of the 5 finalists for Ms. Hockey in Minnesota. Katherine went on to star in both soccer and hockey for 4 years at Brown University. During Katherine's Brown soccer career, she earned all Ivy accolades each of her 4 seasons, was named Ivy League Rookie of the Year, and was chosen to All-Region and All-American teams. Katherine graduated from Brown as one of the school's top 5 all-time leading soccer scorers in several offensive categories, and was captain of the team her senior year. On the ice, Katherine was selected to the Eastern College Athletic Conference All-Academic team during her junior and senior hockey seasons. While at Brown, Katherine received the Kate Silver Award, given to the Outstanding Freshman Varsity Female Athlete. And she also won the Marjorie Brown Smith Award, given to the Outstanding Female Varsity Athlete her senior year, becoming one of just 6 athletes ever to receive both honors in the school's history. She received her bachelor's degree with a double major in sociology and community health. A distinguished collegiate soccer career led Katherine from Brown University to Iceland, where she played soccer professionally for Club Breidablik. Katherine has turned her passion for fitness and nutrition into a successful business career. She is the co-founder of OWYN, stands for Only What You Need, so also said OWN. It's a plant-based nutrition brand sold by retailers. You might have seen this brand in Whole Foods, Vitamin Shop, Sprouts, Fresh Market, Amazon, and liveown.com. Prior to OWN, Katherine was the co-founder of VROU, V-R-O-U. It's a line of high-density nutritional hydration beverages, which was acquired in early 2017. Today's award honors a member of the alumni community who was active in athletics at Blake and who has continued to excel in his or her athletic endeavors beyond Blake. We honor Katherine today with this citation. And I'm looking for Katherine out there. Right there, okay, found you. We recognize you for your, for your highly successful soccer career and hockey career at Blake, at Brown University, and as an All-American athlete. Additionally, you achieved professional status as a soccer player in the international sports arena. We also recognize you for founding OWN and VROU. Your profound and continued dedication to health and fitness has inspired and supported many in their personal wellness journeys. Thank you, Katherine. Congratulations, Katherine. It's my pleasure to present to you something we use in Minnesota quite a bit, which is a blanket. And thank you and honor you as 2018 Alumna Athlete of the Year.
Thank you so
Thank
much.
you so much. It is my pleasure to introduce and pay tribute to our outstanding Alumnus of the Year for 2018, Dr. Donald McCarthy, class of 1966. During his time at Blake, Dr. McCarthy earned 8 varsity letters in cross country, wrestling, and track. He was also yearbook editor and active in dramatics and the science club. In his senior year Calipan entry, there was this musing about Don. His fierce dedication is a quality which will make him a success in college and in later life. How right that author was. Dr. McCarthy is a distinguished researcher, astronomer, and lecturer at the University of Arizona's Steward Observatory, where he has pioneered techniques for achieving high angular resolution at infrared wavelengths from both ground and space-based telescopes, even detecting atmospheric waves on Pluto. His passion for astronomy began with the launch of the US space program when Don was in 3rd grade. He went on to attend Princeton, where he received his bachelor's degree in physics. His own rigorous educational experience inspires him to teach others, particularly first-year non-science major students who may have limited experience in math and the sciences. In 1989, Don began leading astronomy camps that continue today, and they attract teenage students, educators, schools interested in participating, and also adults from all around the world. A multifaceted teacher, Don helps others see and influence the future. This award honors a member of the alumni community who has demonstrated outstanding leadership, achievement, and influence in his or her field and community activities. I am very pleased to recognize you, Don, today with this citation. You have distinguished yourself through your passion for groundbreaking research, as well as a creative and passionate commitment to teaching. At Blake, we value and cultivate academic rigor and passion amongst our students and faculty. You too have embodied these values and pursued the best in education and intellectual advancements. You not only have contributed to your field through your innovation and discovery, you have creatively and enthusiastically brought your vast knowledge to all ages and levels of experience through your astronomy camps. The Blake School is deeply honored to bestow this recognition upon you. Congratulations, Don. It's my pleasure to introduce you now and also present you with an engraved crystal bowl as a token of our esteem. So thank you. All right.
Well, I guess I have to earn that now, huh? So I was told to talk for 20 to 30 minutes. It may actually go longer. I hope you'll indulge me with the notes. This may be an unusual presentation, but I knew that standing here would be emotional, and I didn't know where it would go, so this will keep me on track, I think. So Blake's impact on me has been quite profound. It's taught me to think and to express myself. At least I hope I illustrate that here today a little bit. And it's taught me to teach as a byproduct of all the teachers who were here during my tenure, which was from 3rd to 12th grade, although I took a year off in 9th grade in Fargo, North Dakota, where my family moved. And I did live on campus when my family was in North Dakota. The house is now gone, but at the base of the steep hill, I forget what it was called. The West House? Okay. And I lived there with Will Fisher and Frank Horton. It's overwhelming, really, to be here. I don't think I deserve this honor because I'm just doing what I was taught, quite frankly, and in the way it was taught. So first, a few, as they call them today, shout-outs, to different classes I was in. Mr. Runkle and Nancy Lane were administrators in the lower school. And I took it for granted that a little 3rd grader could go approach a principal of a school. I would find a rock on the road, a piece of obsidian in this case, and I took it in and he told me what it was. He could also tell me how he folded his napkins into little round balls like some piece of magic. Nancy Lane, as I recall, was very friendly and also had a son who wound up in the Packer organization. Maybe I shouldn't say that. In 3rd grade, I got kicked out of class. I had what's called today a timeout. I was by then already enthusiastic about astronomy and maybe a little too overly enthusiastic for the project we were doing that day. And Mrs. Maxwell said, okay, you better sit over there. In today's language, that's a timeout. In my class, and I may have misspelled people's names, so forgive me. My class was the first to do several things, and one was a language experiment. So in 3rd grade, we started learning through Heinz Otto, German. And I'm still remembering his singing and his passion, mein Hut, hat drei Ecke hat mein Hut. I can still say that. I think I can say that. Okay. 5th grade, shop class. I'll never forget Fran Johnson and all the projects that we built. And he's telling me, okay, you don't need to grip the handle of that saw quite as firmly. Just relax. I'm still putting that into practice, I think. But I still have my shoebox, my lamp, my bowl on the lathe. I don't know if that's true for some other people in the audience, but I have those things. 5th grade was also traumatic. And it's ironic today that I literally teach college students fractions, because I remember being in tears over them in 5th grade. So I've come a long way. Mr. Lundholm, Harold Lundholm, taught me how to do logarithms. And this was in 6th grade. This is not normal today. Even my astronomy majors don't recall logarithms. But here's how Mr. Lundholm taught me to remember the logarithm of 2. 0.30103. It's a happy face. That's the best I can do with my graphical ability. It's a smile, there's a nose. You get it? Okay. You have to smile with logarithms, right? Yeah, well, the eyes are there. So, but hardly a week goes by when I don't share how to remember the log of 2 with an undergraduate student, as nerdy as that may sound. Mrs. Lanholm taught us mental math. She would be walking around the classroom, 2 times 3 divided by, and we had to keep up and concentrate with that, and now I'm doing a lot of mental math. I teach that. Our class was a calculus experiment as well. We were targeted, at least in 7th grade, to be the first graduating class that had calculus in the school. So someone thought that out well in advance and started to prepare students ahead of time. I forgot the boxing tournaments, which you could probably never have today. School-wide boxing tournament. And Olympic days, I don't know if you still have them, but what a terrific tradition, and taught me a lot about discipline and athletics. Speech was a mixed success for me with Mr. Fisher, but maybe I survived. I lived with Mr. Fisher in the West House. Anyway, on and on and on. Haji in 11th and 12th grade, I have specific memories of that, as I imagine all of you do. My only regret is that at the time, Blake students were required to take 2 of 3 science classes, chemistry, biology, and physics. I regret not having the biology. I could use that. I still have not today had a biology course. Track and field, Jack Fecht was new on the faculty about when I was a junior or senior. And he knew that I had goals, and he took my diet and did like a little calorie analysis. Here's what you need to do to put on some weight. Over and above what teachers normally do in my experience. I can still remember Don Mazenga out looking out the cafeteria window, weightlifting as part of his fitness thing. So, and the English. The English I read today in college classrooms is horrible. In fact, many of my colleagues can't write a proposal very well. And it's very tiring. In fact, it's almost, my training here at Blake's almost an impediment, because I cannot read anyone's work without saying, oh God, the subject doesn't match the verb. I'm diagramming the sentences in my head. Just as I was taught. What I have to do, and I have to explain this to students every semester, I have to circle, underline, because it relieves my guilt of reading this. And brings to their awareness what they could be. So I will never regret any English course I ever took here. Even the impromptu poetry that Keller Pollock made us write. Unbelievable. So I've had terrific role models and mentors, and without knowing it, because that's the environment that I grew up with here. Chubb Bettles was a very special person to me, and those are some of the quotes that I remember his saying. Those are still relevant. I live those every day. In January, I got totaled by a car on my bicycle. And so I have learned, those quotes have been put into action daily over the last 9 months now. So anyway, the teachers I've had, I try to model. It's what I understood teachers to be. And now I know that's unusual, but that's what I try to do. Basically, I'm just an average guy. I didn't, maybe I sort of excelled, it says cum laude over there, but there were people far smarter and far more athletic here than me. And I learned from every one of them. I try to put myself in a situation where I'm always surrounded by better people, because I learned from that. It can be a little stressful and can make you feel a little low, but I have always put myself in those situations deliberately, and I've learned from it. What happened here? I remember Bob Schnell. We sent four undergraduates to Princeton in my year. So I was one of 4. And I remember sophomore year getting a D in theoretical mechanics. And Bob said, "You're majoring in physics?" So I have literally failed my way to success. I failed as an astronaut candidate. They picked Sally Ride, which was a great choice. I made a discovery in 1985 that was later disproven, but that's how science works. That discovery changed the field, okay? There were books written about this, and that's what science is. Science and athletics are all about failure, right? You do an experiment, you fail. You swing, you miss. 2/3 of the time, a baseball player doesn't hit the bat or the ball, right? You learn from failure, and I think that's something we need to teach more. So I literally stumbled into teaching, and it was because of trying to explain words like infrared speckle interferometry to my parents. People who you value, you want to make sense of. So I literally, Ruthie Bean, nodded her head when I said infrared speckle interferometry when I was done, and oh, that's a little encouraging, so I keep trying. And I would take family and friends to telescopes. There's Kidd Peak National Observatory. Tucson's surrounded by telescopes and mountains. And these were off limits to the public. And yet family and friends want to know why you're spending 1/4 of your time, 24 hours, several times a month, on a mountaintop. What the heck do you do up there? So we'd sneak my son, my daughter, different people. I think we took Connie up there once. Yeah. And it's sort of like, and you'll see this in the next slide, I read obituaries these days. And one of them was about a guy, a NASA scientist named Frank McDonald. His students who wrote this lengthy obituary are describing his life, his hobbies, his approach to education and research. And finally at the end it says, his approach to administration was proceed until apprehended. Because then you can ask for forgiveness, you see. And so that's what we were doing, taking people to telescopes, sneaking them in. And so my interest expanded. The astronomy camps were not my creative thing originally. Ray White was a member of our faculty, and he came up with this idea of taking children of alumni to the telescope facilities. And at the end of his first summer of doing that, it's a 1-week camp, he said, well, Don, would you like to do this instead? Because there's one thing I've learned, and that's that I hate teenagers. I happen to love teenagers. And so we've resonated and built the camps into something that has grown tremendously in very unexpected ways, which is true, I think, in general for education. So I began teaching somewhat accidentally, a substitute in different astronomy classes in Arizona. And actually, I'm still not paid to teach. Your equation is research, teaching, and service. Oops. And historically, from the way I've been brought up through the system, it's just research and service. So I'm a volunteer teacher, but that's all I'm doing this semester. I can tell you that. So this is emblematic of Astronomy Camp. We literally are exploring together in the ways that I saw students here yesterday exploring together robotics. Free exchange, adults, kids of all backgrounds, interacting, learning from each other. That's the environment that we have, and it comes from Blake. And these 6, I think, tenets are some of the things that have made Astronomy Camp successful. I believe they're also all illustrated here at Blake and just come naturally to me because that's the environment I grew up with. This is the result of actual educational research with students who've attended the camps. So the camps have had unintended consequences, and I think education does that in general. You have no idea what the investment is you're making in a child and until maybe 10 or 20 years later. And astronomy camps have been going on for 32 years, and so I've seen this. I've seen kids get married to each other. They've enrolled in my university. Next fall, we will have our first faculty member in my department who was a kid when he attended camp. Who knew, right? He's far better than I am. 42 PhDs in a variety of fields, master's degrees, kids who are successful. Kids, see, I shouldn't do that after 32 years. 18 PhDs in astronomy, they're already colleagues and maybe even competitors. The camps become the basis of educational proposals. So when we wrote our U of A proposal for the James Webb Space Telescope, it had to have an education component at the time. Since then, NASA's changed its mind, big mistake. But anyway, we had it. And so we proposed to partner with the Girl Scouts of the USA, which we're continuing to do. So we teach adult volunteers basic things about astronomy and space science, and this led to the creation of 15 new Girl Scout badges that are being released now. And we've even had family, very wealthy members of family, this would take you over the top, right, of 77 to 80, donate huge amounts of money to the University of Arizona. If you come to Arizona, we have to take you through the Mirror Lab. It's now called the Richard Karras Mirror Lab. because Richard Karras was the grandfather of former astronomy campers who had an awesome experience over a period of years and decided to give money to the university. Who would have thought that would happen? These days, I'm also, because of the outreach I do, a dorm dad, and a sorority dad. So I cook and serve s'mores every Monday night to 200 students in an 800-person dorm. Every Monday until like 10 or 11. That's when students are active, right? So you gotta go where they are. But probably my most surprising publication out of all the research and all that is this one. This is a sorority national magazine. Do we have any Alpha Chi Omega people here? Okay, awesome. So it turns out in taking girls underneath the sky and pointing out the space station and the moon and Mars and various things, I said, there's your star. And they said, what? And they had no idea since 1885 that their badge symbol, which is a Grecian lyre, is an actual constellation in the sky. And so you can make, I made for them in their colors and their badge symbol, their jewelry badge, an electronic shirt, which is rather similar to what your students are doing here at Blake and robotics labs. It's called e-textiles, electronic textiles. You can sew circuits, and you can get kids, especially young women, introduced to computer science in a fun and realistic way. So, who would have thought that probably my best ever publication is in a sorority national magazine? These are important principles to me for education, and I think they reflect Blake values. The mind is not a vessel to be filled, but a fire to be lighted. The students I met with yesterday are on fire for what they're doing. The enthusiasm is boiling over. And the same thing last night at the Star Party. The enthusiasm, tremendous. In fact, those kids could take my college classes, easy. In fact, I once had a second grader in my college class, and he changed the dynamic of the whole class. Kids said, whoa, he's smart. And I said, yeah, he's smart, but he's really just passionate for what he's doing. And we need to bring that passion to whatever we're doing. Inspiration. I can't count the number of times that some teacher here, like Fran Johnson with that saw, made some simple comment to me that I still remember and inspired me. It might have been Mr. Lundholm, oh, you got that geometry problem. Jack Feck saying, oh, that's the best move I've seen on Paul Goldsmith ever. and that only happened once, I think, okay. Teaching is rewarding and yet challenging. So I encourage my students to doodle in class. These are just a few of hundreds. When I retire, I'm going to put these in a book and selfishly profit from it, I suppose. But I have students doodle. And sometimes that's the result of their misconceptions. Did you know that there's no gravity on the moon, and that's why astronauts have to wear heavy boots? Think about that. There's no gravity on the moon, and that's why astronauts, okay. Or the person who took one of our projects, it's called a barn door tracker. It's basically two pieces of wood on a hinge. You put a camera there, aim the hinge at the North Star, and you can take a long exposure picture. Well, a student went back to the dormitory and said, I want to put my mother's 35 millimeter camera on there. Will that work? And she phones back and says, yeah, the thread, the pitch of the screw will match. Oh, but I had a thought going back. We're going to take pictures of the stars at night, right? Yeah. Don't I need a flash? And that, you don't know how to answer something like that. It's certainly not over the phone, okay? So there have been all kinds of these light bulb moments and challenges. Teaching is challenging as you encounter people with different backgrounds. This is one of the challenges. It's revolutionized the way that I think. How many of you can do this math problem? Be honest about it. And if I asked you how many, those of you who said you could do it, how you did it, you'd say there's a rule. And when the fraction's in the denominator, you say you flip it. And those of you who don't remember would often tell me that you don't remember it because you've forgotten the rule. It's always a rule. But if I said, what does it mean? And this is what I was taught to do at Blake. It means how many halves are in a whole. Everyone knows that. Why can't we teach math this way this is irritating, with what it means as opposed to just the rules and process all the time. Math came alive here for me especially after I mastered fractions. Could you, on this number line, put a billion down? So that's meant to represent from left to right the number 100, or 1, steadily increasing to 100, or a trillion. I don't know why I got 100. 1 to a trillion. Where's a billion? Last week I had a course starting. No college student in that course could correctly answer this question. A billion is 1,000 times less than a trillion. It's E. But in a typical class, maybe 1/6 of my students know this. This is the language of the economy. So I tell them, at this point, you shouldn't vote, right? That leads to some discussions. These are quotes that my students have, some of them honor students. I've never seen science and math work together. I want to come to your camp because I hear that science and math go together, but I've never experienced that. Blake gave us a holistic education. And so I've always taken it for granted that these go together. Reality is mathematical in nature. No wonder I'm so poor at life. That's a student's doodle. Okay, where is astronomy headed? I'm probably well over time. Let me give you a clue for where that's heading, and that's a challenge to education as well. It's a new era of precision. We're measuring the universe to parts in a billion. Now that I've told you what a billion is, maybe that should be better. We are finding planets around other stars, now some 4,000. Here in this graph, you see the stats. On the left, the mass of the planet in terms of Jupiter. If you look at the number 1, you'll see Jupiter at the far right. With me? Horizontally, it's the duration, it's the year of the planet's orbit. So Jupiter goes around the sun it's in days, but it's 11 years. Do you see anything unusual about that? Look at the black marks. Where's our solar system? All non-typical. We are learning what planets are like around other stars. It's some of the work I do. We can analyze the planet's atmospheres. Not too long from now, we'll find out if those planets have oxygen in their atmospheres or not. Either way, that will be a profound conclusion. And we need to confront the idea that our solar system is not common, but part of a common process that's just played out differently for some reason in our case. This picture is like a laser dot on the sky, if you could see it with your eye. There's 10,000 galaxies in here. Every fuzzy thing you see is a galaxy of 100 billion stars. This particular area comes in groups. It's a cluster of galaxies. In these places, here, those 4 places, there's a background galaxy. So you're on the Earth, here's the cluster of galaxies. There's an object in the distance, a galaxy that has been multiply imaged because the cluster of galaxies has bent space. This is real. In fact, if you don't believe it's real, I'll collect your cell phones in the back as you exit. Modern technology is based on these ideas. That space is tangible in the sense that it can be manipulated, and it bends the direction of light. Well, Patrick Kelly, who attended our camp, is now a professor at the University of Minnesota. His father is an alum of Blake. He made this discovery that a supernova, a star exploding in that very distant galaxy, was multiply imaged 4 times. It's called an Einstein cross. And he revolutionized astronomy and predicted that that supernova would then show up on one of the other paths that light took going through that cluster. He predicted a supernova. That's hard to do, but only because we know the geometry of the universe. And then a couple years later, that same gravitational lens, it's called, magnified a single star. He detected a single star in that distant galaxy, a normal star, not an exploding one. Because the gravitational aspects of the cluster magnify the light like a lens, like a natural lens. And so this is only going to continue as we explore the universe with higher precision. Come to Arizona, take a tour of the Mirror Lab. On the right-hand side is a project that we're working on where it says 7 mirrors the size of Bovey Chapel, each $20 million, each precisely made to splitting your hair 1,000 times everywhere on the surface, all aligned to billionths of a meter, collecting light and focusing it to much less than the width of your hair. A huge piece of technology. And then we're also involved in the James Webb Space Telescope, which will now be launched in 2 years. This is a 20-year project. It was supposed to be 10 years when I signed up. It's now 20, but it will be launched. And we are building one of the 2 electronic cameras for that at the University of Arizona. And that camera, I'm proud to say, is engraved "Go Girl Scouts," because of the connection to Astronomy Camp, which began with Ray White not liking teenagers, asking me because I like to work with kids. And all of that is based on what I learned here and profited from. And that's where I'll end finally. Thank you.
Don't go, because I'm sure there'll be some.
Oh, yeah. And I forgot to tell you that I've discovered I have Haji's original mimeograph notes that he handed out in his physics classes. Maybe some archive. Do you know what a mimeograph is?
I was looking at your dot plot of the galaxies, and I was thinking, so are you saying that our solar system is an outlier?
You're looking at the graph of the planets here. I am. That one, yes?
Great.
Yeah.
All right, that's all I wanted to say.
Mm-hmm.
We are an outlier.
Yeah, and the current reason for that is that what we were taught at Blake actually isn't correct, because it was correct at the time, but not today. The planets were not born in the orbits we see them. They have all shifted. Jupiter moved in and scrambled the solar system for reasons that we could discuss. And that devastated the inner solar system and led to our being unique somehow.
Are you following any of these missions to Mars?
No, because I want to be on one of them. Yeah, I am. You mean the robotic ones or the Elon Musk lifetime trip?
It sounds like there's many of them. I have this popular mechanics magazine on Mars, and they're talking about all these different countries racing each other to get there.
The era we live in is exactly like the 60s. I grew up in the era where I'm in the only generation in my class that has seen every single space launch. The first view of the whole Earth from space as a round ball that probably inspired the environmental movement. That's unique to our generation by accident of birth. And so, yeah, I'm excited about that. And I do follow all those missions. Some of them come from the University of Arizona. We have a bias, I think, in science. And one of my astronomy campers put it really well. And he saw pictures like the galaxies in the next slide and says, wow, there must be life elsewhere in the universe because of the numbers are overwhelming. I agree. But he said, if we didn't discover life in the universe, it wouldn't be fair. But it would be fair. The universe, it turns out, has to be precisely the way it is, from start to finish, in its recipe, in its power and energy, or we wouldn't be here at all. Our existence depends on the little atom. It depends on the universe being this size, this old. So we're biased to finding life, and that's what's dictating the missions to Mars. We got to find the water, and we got to follow the life. And I get that, but it's like a fear of being alone. And I think we could have, well, it is psychologically. So it's all very exciting, and some of my astronomy campers are driving those rovers around the surface of Mars and planning for the next ones. It's quite amazing. Did I come close to answering your question?
It's a big question.
Okay.
What do you think of the work that Bezos and Musk are doing with the lifetime effort?
What do I think that the current generation of billionaires is doing with space? I think it's awesome. I have a little mixed emotions when I see a car being launched into space permanently. It's like I grew up, like I said, in this generation that treated space as like a frontier, like it's sacred, right? But now we're launching a Tesla car with a dummy robot in it, right? So, but I think it's tremendous, and I think those guys grew up in the same way that I did. During my astronaut interview, we got there for a week, and they said, write an essay. In fact, this is what we do for Astronomy Camp. You have to write an essay why you want to come to Astronomy Camp. And at the NASA interview, they said this. And well, my interview was the next day, so I stayed up all night, kind of like I did last night, and wrote this essay. And after all is said and done, they published an article saying that the interview committee was surprised that all the people they interviewed were inspired by Mercury, Gemini, Apollo. How can you be surprised? I mean, that was just life-changing for kids growing up in that era. That's to not recognize that it had that effect on society is just amazing to me.
Don, fellow classmate, we're proud of you, class of 1966. I think you're the only accomplished graduate from that class. Thank you very much. Some scientists posit that the universe may have no beginning and no end. What's your take on that?
Well, I would disagree with that. There's certainly room for disagreement. It's a big universe, right? All the signs, and they're very specific signs, point to the idea that the universe had a beginning. Now, it could have had a beginning before that. It is possible that what we see as an expanding universe today, and we play it back in time, came to a point. We're talking about space and time themselves, by the way. This is hard to imagine. When you think of cooking a pizza, it's in an oven. We're talking about the creation of space, so there was no oven. But space itself might have come into existence from a prior existence, like a funnel, like an oscillating sort of thing. And maybe the dimensions were switched backwards and forwards. People's imaginations go wild. But that's what science is, and that's why it's fun. So the universe we currently live in had an origin in time. It didn't have an origin in space because there was no space to have an origin in. It's the creation of space itself. And that plays out today in ways you can measure to 1 part in a billion. It's amazing. Now, there could be other universes. And the going term today is a multiverse, all set up differently, and we shouldn't be surprised that we live in the universe that's conducive to life. It has the right speed of light, the right gravity, the right kind of atoms. The initial conditions don't have to be the same. And so we shouldn't be surprised that we live in such a well-balanced universe like that because we're not compatible with anything else. But there could be others. I'm not sure if I'm answering your question, but certainly the universe we live in today had an origin. It might have had a prior state. We don't know because we can't look back any earlier than a trillionth of a trillionth of a trillionth of a second, as strange as that sounds. But we cannot say, well, let me preface this. The University of Arizona has collegial relationships with the Vatican Observatory, the observatory that kicked out Galileo. Okay? They teach our classes. We do research together. They have their own telescopes in Arizona. A Vatican Observatory cosmologist once said in a talk, and I agree with this, we can't tell you where the original matter and energy came from. We can't tell you why the Big Bang happened, but it did happen. That's my take on it.
How about the end? The end of the universe?
The end is debatable. We're still learning. Would you trust an astronomer who told you I didn't know what 95% of the universe was? It's true.
Yeah, more than one who lied about it.
So we're made of nothing. We're made of 4/10 of a percent of what the universe is made of. Okay? We don't know what dark energy and dark matter are. It's kind of like what Donald Rumsfeld said, there are known knowns. These are things we know. There are known unknowns. These are things we know we don't know. That's dark matter and dark energy. And then there are unknown unknowns. These are things we aren't smart enough to think about yet. And that's the journey of science. That's what makes it fun. But 95% of the universe is a known unknown. So don't trust whatever I'm saying. Come back in another 50 years and hear some of those kids that I met last night give this speech. Okay.
Any last questions? Well, Don, that was great. Thank you very much. Don, before you take this, My daughter is an Alpha Chi Omega, and so can I buy this from you for her Christmas present? So
I'll make her one.
That'd be great. Thank you very much.
Great organization.
Terrific. In this world of GPS, it's hard to think all the way back to the Greeks navigating by the stars in astronomy. But what's amazing is I think of my father, class of 39, in World War II. Many of your fathers, grandfathers were. He was a navigator. They navigated by the stars. There were no scientific instruments that helped them. The radar was brand new, and that didn't help navigation. It was all through the stars. So it's not that far in the past. And then to bring it into the future, I'm sure many of you, like me, today were listening to KQRS on the way to breakfast. And on the morning show, Tom Bernard was talking about the fact that a gentleman just discovered that his 22-pound doorstop that's been in his family for 30 years was a meteorite they found it, family found it years ago in Michigan. So anyway, astronomy is relevant. So is Reunion, and we've got the Great Events Tour in 15 minutes. Great Blake get together in the arena, a homecoming game at 7 o'clock, and a month from now we are going to have the Young Blake Alumnus of the Year speak, Eric Dayton. Hope you'll join us for all of those events. Thanks everybody for a great breakfast.